We're out at the horse park for the USA Dressage Finals, and we ran into a really good opportunity to talk to one of our researchers for the Grayson Jockey Club Research Foundation, Dr. Bettina Wagner. She is the James Law Professor of Immunology at Cornell University. Her laboratory, we're just going to skip all the rest. Her laboratory focuses on research in equine immunology, and they particularly interested in immune responses, protective mechanisms in neonates and young foals. But also the disease models include intracellular pathogens such as equine herpesvirus. She's currently working on a DNA platform vaccine for EHV1, EHV4, for a project that is funded by the Grayson Jockey Club Research Foundation. And we would like to ask her kind of where we are with that project and to explain simply what you're trying to do.
Yeah, thank you for the introduction. And yeah, so we are about 1.5 years into the project right now, and our next steps will actually be to go into the DNA vaccination approaches. So basically the vaccine development is currently ongoing, and the next step will really be to use the vaccine in horses. And the past 1.5 years we actually used to define the best protective antigens for the vaccine that we are developing. So taking a step back, so what we did initially, or what the hypothesis here was, that we wanted to use the immune response of horses that were protected against equine herpesvirus, which means horses that did not get infected and did not shed virus and did not develop viremia when they were exposed to the virus. So, and we took basically samples that we had banked from these horses, and had in our freezer serum samples mainly, but also PBMC, and we tested them with different proteins, so surface proteins, glycoproteins of equine herpesvirus, which are actually immunogenic structures for the virus, for the immune system of the horse. And so we just did that. We expressed about 20 different proteins of both EHV1 and EHV4, and run them basically in many tests against those samples, banked samples from the horses, to define 4 of those antigens that will go into the newly developed vaccines. And so again, that's ongoing, and we will see how that goes. We're very curious to see how they work actually in the horses.
So you're down to basically your 4, what you feel like are the best candidates.
Yes, those which gave really the highest responses in the horses that can be connected or associated with a protective profile, phenotype.
So this vaccine, obviously, for us and the industry at large, is very important. I mean, EHV costs the horse industry millions of dollars every year.
Yeah.
From quarantines at racetracks, horse shows, you name it. It's a difficult situation when you get an outbreak, and it does cost a lot of money, time, and effort for the horsemen. One of the hopeful ends to this, probably, I think, would be a protective mechanism against EHM.
That is correct. Okay. Yeah, that is absolutely correct.
And that's obviously, as we all know, is kind of the worst of all scenarios when you have a horse that's diagnosed with EHM at any kind of event or racing, showing, or whatever. So we're very hopeful that Bettina's project is successful, and we really appreciate the work you do.
Yeah, thank you. And we appreciate the work you do to enable our research. I mean, it goes hand in hand.